This study investigates the effect of a domestic hen's age on both the laid egg's weight and the egg's equatorial shell thickness in free-range flocks in New South Wales, Australia. This study considered the domestic chicken only. Egg production of the domestic chicken is affected by the hen's age at point of lay, or the time at which it is laid. Specifically, the hen's age affects the number of eggs laid, the size of the eggs produced, the weight of each egg laid, and the eggshell's thickness, amongst many other factors. Each of these factors are known to affect the profitability of such egg-laying enterprises. This is particularly important in free-range egg farm systems, as this type of production requires more land and more hens to produce the equivalent number of eggs compared to caged systems. There are also an increased number of environmental risks due to less efficient use of resources, difficulty in managing egg hygiene, an increased mortality rate, and inability to restrict the movement of hens. Egg weight is the primary criteria used to grade eggs in Australia, so it greatly influences an egg's retail value, especially as the public demands bang for their buck. Given that an egg's weight also affects eggshell thickness, the thickness of the shell can also affect profit margins. This is because research shows that thinner eggshells weigh more than thinner eggshells, so contribute to the overall weight of the egg. Furthermore, larger eggs often have a deterioration of eggshell strength due to their sheer size, as well as the fact that they're generally laid by older hens. Thus, eggshell thickness is strongly linked to profitability, as thin shells increase the chance of damage or breakage, which results in loss of produce and profit. The aim of this study was to determine whether a hen's age at point of lay affects a laid egg's weight, and whether an egg's weight affects the thickness of the eggshell at the equator. When considering egg weight, the independent variable was the hen's age, and the measured dependent variable was egg weight. When considering eggshell thickness, the independent variable was egg weight, and the dependent variable which was measured was shell thickness. Egg weight reflects the total weight of the egg measured in grams, whilst shell thickness refers to the thickness of the egg at the equator measured in micrometers. The controlled variables include the general New South Wales location and the free-range farm type. The University of New England Applied Research Skills in Environmental and Rural Science Unit supplied the data set with vigorous measurements based around egg quality. The total number of 60 eggs were collected from layer hens at 26, 37, 50, and 60 weeks of age, and were from 7 different free-range flocks in New South Wales. At each of the 7 sites, 60 eggs were collected from each age group of 51 hens to form the total data set of 1,680 egg measurements across the breadth of the study. The computer program R was used to explore the data using a variety of statistical summaries before assessing for homogeneity and normality. 2 types of statistical measures were undertaken. The first measure was a group analysis. A one-way ANOVA using pairwise comparison of means was conducted to assess whether the age of a hen affects egg weight laid. This method was chosen to measure for statistical difference among the means of 2 groups and was followed by the use of the ad hoc test Tukey HSD to identify where significant difference lies. The second measure was an association analysis. A regression model was then used to investigate whether a relationship existed between the variables of egg weight and shell thickness. For both tests, the 0.05 level of significance was used. The mean weight of eggs laid for each of the 4 age groups was then graphed in MX MS Excel, including their standard deviations, which were also calculated. Shell thickness against egg weight was also graphed using Excel across the 7 flocks before a linear regression line was added and covariance calculated. The correlation tests identified that significant positive association exists between a hen's age at point of lay and the weight of laid eggs. Ad hoc testing identified that a significant difference existed between the hen's age and laid egg weight between all groups except for the eggs weighed at 50 and 60 weeks of age. Or in other words, as the hen's age increased, the egg's weight increased until the age of 50 weeks, after which no further statistically significant weight increase was detected. The mean weight and standard deviation of egg weight for each of the 4 hens age groups at point of lay is shown on the graph on the screen. The correlation tests identified a slight positive association between the egg's weight and its shell thickness at the equator, with shell thickness being predicted by the formula shown at the bottom of the screen. The overall model fit for R2 was 0.02, indicating a 2% or weak positive relationship existing between egg weight and shell thickness. The coefficient of variance, however, was calculated to be 14.92, indicating a positive relationship between shell thickness and egg weight. A graphical representation of the data points is shown in the graph on the screen. This project adds to the already extensive field of research on the factors that affect egg quality. However, this study is the first to focus on eggshell attributes in an exclusively free-range flock in the New South Wales area. This study has identified clear correlations between a hen's age at point of lay and mean egg weight, as well as a positive association between egg weight and shell thickness. These findings are supported by previously published peer-reviewed literature available in the references section of this presentation. Both the number of eggs laid by a hen and the weight of those eggs depends on the hen's age at time of laying. It is also a well-known fact that eggs laid by older hens tend to be larger in size. This study found, however, that there was no statistically significant difference in egg weight between hens aged 50 weeks and 60 weeks respectively at point of lay. However, hens remain in the egg-laying industry until 18 months of age when they are deemed spent as they become unprofitable. This study did not consider whether a hen's age at point of laying affected profitability. However, it can be inferred that larger eggs bring in a larger profit as consumers demand bang for their buck as they follow the mantra, bigger is better. There is evidence that although larger eggs result in greater profit margins for a business, that eggs often show a deterioration of eggshell strength as they increase in size, which can result in losses of profits due to breakages during transport or stocking of shells. It would be interesting to examine whether the thickness of an eggshell declines as the hen ages, as previous studies have indicated that larger eggs are prone to breakage. It is not known how this data was collected, so it is difficult to determine the validity, accuracy, reliability, and independence of the dataset and statistical results. Specifically, it is not known whether a standardized scale was used to measure egg weight under standard conditions of temperature and pressure. It can be assumed, however, that the data is reliable and accurate as a relatively large number of measurements for each parameter was collected and the results match the results found in peer-reviewed literature. The absence of long-term data, however, limits the usefulness of the results. Furthermore, egg laying is a complex biological and physiological process that can result in a number of deterioration factors which data was not collected for, which could affect the study's design. This project found that there is a positive correlation between egg weight and shell thickness when it comes to free-range eggs on New South Wales farms, supporting previous peer-reviewed evidence that the coefficient of covariance indicates a positive linear relationship between egg weight and shell thickness, as does the coefficient of determination. Given that it has previously been shown that a thicker shell can be influenced by the housing system being utilised, the period of time the egg spends in the uterus, and the rate of calcium deposition during formation, these statistical outputs make sense. It was also found that a positive correlation between hen age and egg weight up to 50 weeks of age exists. It is questionable, however, as to why the age at which hens are deemed spent in the industry is 18 months if there does not continue to be any correlation beyond 50 weeks. An interesting further direction of study could include assessment of whether a hen's age at point of lay affects a shell's thickness, or whether a positive relationship continues to exist between hen's age and egg weight in caged egg farms. A full set of references and statistical calculations and output are available on request. Thank you.